Okay, good morning, everyone. Thanks for being here, and bear with me. I've got a few hours of sleep, but I'm very excited about this presentation. So let's kick it off. Today we're going to talk about how to, well, a little bit of the basics of zero knowledge proofs and how to turn Ethereum into a global settlement layer. We're not going to go or delve that much into the detailed technicalities of it, but the general idea and how we can turn it into this global settlement layer. So first things first, what even are these zero knowledge proofs? These zero knowledge proofs are a way to prove that the validity of an argument or a statement without revealing valuable information. Most of us probably already know that in here, but it's very important to cover the basics. If you want to go a little bit more detailed about it, it's a method in which one party, known as the prover, can prove the validity of a statement or an argument to the verifier without revealing any type of confidential information or any type of information at all, like besides what this verifier needs to know in order to confirm that this argument is true or valid. Here there's a small graph, prover and the verifier, main participants on this interaction. And whenever we talk about zero knowledge proofs, they need to have three main characteristics. First one is completeness. If this argument is true, it will return the value of true. There won't be a way of lying or deceiving this mechanism, because it will provide the true value if your argument is complete, valid, or true. Soundness. This goes to the fact that, or what we just mentioned, you cannot lie. There's no room for deception or deceiving the verifier. This is a pure interaction and it's based on mathematics. So there's not really that room for malicious intents or for trying to avoid or deceive this third party. And zero knowledge, which it's in its name, it's pretty obvious, but it's very important that the confidential information that we're talking about or that is being utilized to create this response is not shown or is not made public. So why zero knowledge proofs? We know what are, but why exactly? It improves the security of information or the privacy of this information for users. It enhances scalability by reducing the amount of computation that has to go into Ethereum, and contribute to a blockchain's overall security, because data and transactions are validated not by a third party, but by the system itself, and, as we mentioned before, mathematics. So, going back to the first part, or to the first point, scalability. Whenever we talk about layer 2s, there's this small example that I like to utilize. I was able to tell my grandma what is an layer 2 with this example, and she understood, so I think it's kind of like a successful one. If we can think of Ethereum as the most decentralized and secure highway in the world. You can get from point A to point B in a very secure and decentralized manner, but not in an efficient manner. Why? Because every day during rush hour or during most part of the day, there's a lot of cars, a lot of vehicles going from point A to point B, a lot of congestion in this highway. So you have the security, you have the decentralization, but you don't have the efficiency. It cannot scale per se. So this makes up not a great experience for users, and a way in which we can introduce a better experience would be through layer 2s. We can think of layer 2s as an external lane in this highway that is only for collective vehicles, only for collective transportation. So we're taking advantage of security, taking advantage of decentralization, and we're introducing this collective transportation lane. By users being able to go into this collective transport, they don't have to make these huge lines on each individual in their own car. They don't have, so less congestion. They don't have to pay the individual toll themselves instead is divided among all the passengers of the bus. So it's also more economic for them. And we end up utilizing the security and decentralization of this extremely prominent highway and scalability of this external lane. So this is why it's so key, and this is why it's been such a big topic among layer twos, because zero knowledge proofs can help with this scalability and to really transform Ethereum into that settlement layer. Here are a few examples of this scalability issue. In the past, we've seen gas wars. We've seen even like during the whole order deeds and like Bored Ape Yacht Club things, we saw people minting NFTs for close to $50,000. Here's a little like a meme just for the laughs, like don't be like Thanos. But like, in all honesty, like Thanos does have a point, because I mean, Ethereum is the most secure network, right? So that takes us to the second point, which is security of information. Whenever we're referring to regular traditional frameworks or databases, they tend to be centralized. So guess what? They get hacked, you get hacked, your information is lost as well. But in order to hack Ethereum, well, like that's gonna take a lot more, you know? So it's way harder for malicious entities or parties to exploit this information. I'm not gonna say impossible, but way harder. And the blockchain's overall like security, by not having to rely on third parties and having this mechanism kind of like in the process itself, kind of like the prover and the verifier, it can keep the, I lost the word, but it keeps it pure, it keeps it confidential, and it keeps the system pretty tight, airtight. So here's the basic formula of how like snarks tend to work: function being evaluated, public input, private input, and we get ah, my bad. Better or not?
Oh, really? Let's plug it.
Almost.
Let's unplug it and plug it again.
Can you hold here for a sec?
Have you tried turning it off and on again?
Put it in rise. Cool. Cool. So the function being evaluated, public input, private input, and here's where you would get the value that we're looking for. If the argument is valid, true. If not, we're not going to get that true value. So here's where we start going also a little bit like beyond the realm of blockchain. Blockchain is where we've seen this concept really like popularized because of layer twos, optimistic rollups, and then all the buzz around ZK rollups, and which is a pretty legitimate buzz, but it doesn't stop there. One second. Hopefully y'all can get a little peek from here from the computer. Here's where we go in beyond the realm of blockchain. And we could also go into IoT devices. Almost back, almost fully back, yeah. So beyond the realm of blockchain, we can also, like zero knowledge proofs can also tap on or can also secure IoT devices, virtual reality setups, and more. In the sense of virtual reality setups, just to bring a pretty like a quick example, let's think about VR concerts. For example, if there's an organizer creating this concert and they want to sell tickets through NFTs, they don't want to keep any data to avoid any potential issues with the law. So the one way in which they could validate that all of these addresses are in fact valid, or they don't need to keep any information from this, they can validate it through zero knowledge proof, validating if they did or did not, as a matter of fact, have or interact with this ticket or are valid to go into the concert. With other types of games or setups in terms of virtual reality, we can also utilize zero knowledge proofs, and they wouldn't be recording, or no one would have access to any type of biometrics, behavioral patterns, or etc. that we know have been a very discussed or polemic topic lately. Decentralized cloud computing is another realm in which we can tap like zero knowledge proofs, and we can leverage the processing power of other systems and not necessarily just one per se. We can tap into this network of computers and really take advantage or scale this process, decentralized computing. And zero knowledge machine learning, which would be pretty much training any of these models and being able to judge if these models are correct or are providing the right results or not, without needing to access this information, purely mathematically. So these are some other realms in which zero knowledge proofs are starting to, or well, have been there, but like are known for, besides the blockchain boom that we've been seeing. And I do believe we're going to see a lot of growth in all of these like realms. Tapping into ZKM, which was what we mentioned at first, here it identifies some of the main challenges that we see nowadays, which are eliminating withdrawal window, 7 days, unified security for all L2s and L1s, and tamper-proof IoT devices. And some of the solutions that can be put in place for this would be a potential hybrid rollup solution for all L2s, no 7-day withdrawal window. We can use Ethereum as a settlement layer for all L2s and L1s, and we can even go larger and tap into what we mentioned, IoT devices, virtual reality, and cloud computing, all these using Ethereum and ZKM or ZK MIPS as a global settlement layer. Of course, utilizing Ethereum as the main settlement layer. And if you want to know a little bit more about ZKM in detail, like how they're utilizing MIPS processor for the zero knowledge solution, you can scan the QR code that will take you to a white paper, and that will be pretty much it. So thank you everyone for bearing with me. I know it wasn't swift, but we made it. So thank you.